So hello guys, welcome to my channel The Need of Physics, and today we will be discussing about the topic mesh analysis, which we will be discussing on BEE, that is engineering topic. Okay, in this topic we will be solving different kinds of complex circuits, okay, by mesh analysis, where we will analyze a mesh, okay, and so we will start with the problem. So how to solve a given problem using mesh analysis? So in exam, this question comes for 10 marks. So how we will solve them? So first of all, one question will be given, like one resistor would be given. Then a voltage source will be given like this, and one more resistor will be given. Okay, this I am considering one general example. Okay, complex examples such as 3 mesh or 4 meshes will be also given. So how to solve that we will be seeing further. So this is a simple example how we will solve. Let's see. So here the value is given 4, and here the value is given 2, and here voltage source, it is given 28 volt. So how to proceed? Okay, so first of all, we know this is positive terminal, and we know this small terminal is negative terminal. Okay, so we have given the signs properly, and now we will solve this circuit by mesh analysis. So how to proceed? So in mesh analysis, we have to draw direction of current. Like we have to assume it either in clockwise manner or either in anti-clockwise manner. Okay, either in clockwise or either in, sorry, anti-clockwise manner. So this is anti-clockwise, and this is clockwise. Okay, so how to proceed? So first we will assume the direction of current to be clockwise. So after assuming the direction to be clockwise, we will go the circuit in the direction of loop. We will give notations to loop such as A, B, C, and D. Okay, now the question is we have to find current. Question is we have to find current through 2 ohm resistor. Okay, we have to find current through this resistor. So how we will proceed? So we will apply KVL. Okay, Kirchhoff's voltage law. In Kirchhoff's voltage law, we solve a given loop using uh, the law, junction law. So first of all, in this law, uh, on on this side, okay, on this side we write all product of current and resistances, and on this side we write all voltage sources. So current is going in clockwise manner. So first it comes through 4 ohm resistor. When it comes through 4 ohm resistor, okay, suppose I am considering it as I1. So by Ohm's law, uh, the voltage that will be produced across this resistor will be 4I. So I will write 4I. Okay, I will write 4I on LHS in this side. Okay, on this side I will write 4I. Then I will move further to B and C. At BC there is no resistor, so I will move further. From C to D, I am observing a resistor of 2 ohm. So what I will do, here also I will write plus 2I1. Okay, because 2 is connected in series. Then I am observing a voltage source. So the rule is I have to write this voltage source on right hand side. So I will write this voltage source on right hand side. Okay, now I have written here positive 28. Why? Because voltage is increasing. Okay, according to the direction of current, if we move from 4 ohm to 2 ohm, we are moving in clockwise manner. And when we come across this 28-volt voltage source, we are arising from negative terminal to positive terminal. So that's why voltage is rising, and that's why I've written plus 28. So in next case, these two will be added and we will get 6i1. We will get 6i1 is equal to 28. Okay. And now after further solving, we will get value of i1. And that will be 28 upon 6, that is 4.66. So we got the value of i1, that is 4.66 amperes. So this was a bit easy and simple problem because there was only one mesh. In this problem, we solved mesh analysis through one mesh only. In further problems, we will solve by using 2, 3, 4. Okay. So I hope you have got this idea clear how to solve mesh analysis using one mesh. Now we will solve mesh analysis using two meshes. Okay, the question is find the number of meshes and current flowing through each mesh. So I will draw the mesh. Here a voltage source is given. Here I guess it is positive and here it is negative. Here a resistor is connected whose value is 5. Again a resistor is connected in a branch whose value is 10. Here no resistor is connected, only branch is given. Here a 30-volt resistor is connected and here a voltage source is given. So here we can see there are two meshes. Okay. Now what is the difference between mesh and a loop? So first of all, loop contains more than one mesh, but mesh doesn't contain any loop. So what does that mean? Mesh is a only and only one loop. Mesh has only one loop. Okay. So in this diagram, we can see a loop. This entire loop has two meshes. But if we are thinking from the point of view of mesh, we will see that there are two meshes. Okay. So mesh is a smaller part of loop. Okay. So here the value of voltage source is given to be 20 and here it is 20 and here it is 80. Here the direction is reversed. Here the direction is reversed. Okay. And here the value is 80. Now we have to solve this mesh using mesh analysis. So how we will proceed? So first of all, first step, we will draw direction of current. I assume the direction of current to be clockwise. It would be better if we assume direction of current to be clockwise. First loop, I will take I1. Sorry, first mesh I will take I1 and for second mesh I will take I2. Now I can clearly see in these two meshes I have divided I1 and I2. So how I will proceed? So I will apply KVL. In last question I applied KVL to only one mesh. Here there are two meshes. So I will apply KVL to both the meshes separately. So first I will apply KVL to first loop or first mesh and then I will apply KVL to second mesh. In first mesh, we can see that current is flowing first through voltage source, then 5 ohm resistor, then 10 ohm resistor. So we will write first 5i1 plus 10. Now there is a twist. We can't write I1 here because 10 ohm resistor is common between two meshes. Here the 10 ohm resistor, through this 10 ohm resistor, I1 and I2, both the currents are flowing. But here we are considering first mesh. So that is why we will write I1 first. We will write I1 minus I2. Okay, we will subtract both the currents. Why? And why we are subtracting I1 minus I2 and not I2 minus I1? The reason is we are taking first mesh. If we are taking second mesh, then it would be I2 minus I1. Okay. Now I've came across 5 ohm resistor and then 10 ohm resistor. Now I will pass through 20 volt source. So I will write this 20 volt source towards right hand side, and I will give a positive sign to this 20 volt because my voltage source is rising. That is, current is flowing from negative to positive according to its direction. Now I will solve this equation. I will write 5i1 plus 10i1 minus 10i2 equal to 20. On further solving, we will get 5i1 plus 10i1, which is 15i1 minus 10i2 equal to 20. So we got our first equation by first loop. Minus 10i2 equal to 20. Okay. Now what we will do, we have written this first equation. Now rest all I will clear. Now I will apply mesh analysis for second loop. Similarly, what I will do, I will apply KVL. Now I will consider I2. So first I will write 30 I2. You can start with any resistor. You can write also with 10 ohm resistor. So here only I2 is flowing from 30. That is why I have written 30 I2. Okay. 30 I2. Now your voltage source is coming. So I won't write this voltage source because on left hand side, I will write product of current and resistances only. I will write voltage source towards right hand side. So I will wait for it. So here I am coming across now 10 ohm resistor. After going through 80 voltage source, I am coming across 10 ohm resistor. Now how I will solve it? So as per last mesh, it was I1 minus I2 because current I1 was flowing through first mesh. 10 ohm resistor is common to both the meshes. But here we are considering this mesh. So that is why we will consider I2 first. So 10 I2 minus I1. That will be equal to, now we will write voltage source. Now here the direction of current is clockwise and here it is going from negative to positive. Again there is a rise, so we will write 80 plus 80. Now we will further solve. It will be 30 I2 plus 10 I2, that is 40 I2. Okay, 40 I2, and this 10 will be get multiplied to I1. So it will become minus 10 I1, that is equal to 80. So we got our two equations. Now, how to solve these two equations? So now we will solve these two equations on calculator also, and we can solve these two equations by Kramer's rule also. Okay. So as this is a two mesh circuit, we will solve by calculator first. Okay. So on calculator, okay, wait a second. I will erase this mesh because I want only equations now. I wanted only equations and I have diagram in my phone so I can cross verify. So we have got these two equations. So how we will proceed further? So in our scientific calculator, as I've explained in my last video, okay, a calculator would be given. On that calculator, you have to press mode button. Okay, after pressing on mode button, you will get something 8 options. Okay, you have to click on fifth option. Okay, on fifth option, you will get equation. Okay, you will get equation. So after pressing this mode button, we will get equation button. Okay, now I'm using online calculator, which is on my phone. Okay, it has two versions. It has offline version also, and it has an online version. So if you don't have calculator, you can use it on phone also. So as you can see in my phone, okay, in my phone you can see this mode button. Okay, below vector you can see mode button. So you have to click that mode button, and on clicking on that mode button, you have to click on the equation. How many unknowns are present in this two equations? So we are seeing that there are only two unknowns, I1 and I2. So we will click on solve system equations by two unknowns. Okay, we will see this. Okay, we will see a table. We will see a table A where there are headings A, B, C. In A, we have to enter value of I1. In B, we have to enter value of I2. And in C, we have to enter the constants, that is 80 and 20. So I am entering first equation is 40I2 minus 10I1 is equal to 80. So as per our rule, in A, I will enter minus 10. Minus 10. In B, I will enter 40. In C, I will enter 80. Now I will enter 15 for second equation in A. Then I will enter minus 10 to B, and then I will enter 20 to C. I am getting value of I1 to be 3.2. Okay. This is the value of I1, which is 3.2 ampere. Then I'm getting value of I2, which is 2.8. Okay, I got values of I1 and I2. So as it was a two mesh circuit, we solved directly. But in case we are getting three meshes, then we have to solve by a determinant method. That is by using Cramer's rule. Okay, we have to solve by Cramer's rule. So in next we will next example we will solve by Cramer's rule. Okay. So in Cramer's rule, three equations would be given. Like in previous example, we saw two equations were there where I1 and I2 were unknowns. Now in Cramer's rule, in three mesh analysis, we will solve three equations, okay, where their coefficients would be taken, and we will solve the entire three equations by Cramer's rule. Okay. So first of all, here 5 voltage sources given, and 1 ohm resistor is connected in series, 2 ohm resistor is connected in parallel, 3 ohm in this branch, 4 ohm in this branch, 5 ohm in this branch, and 10 volt in this branch. Okay, so in this diagram we can see there are 3 meshes. So we will solve for each. Here the value is 2, here the value is 3, here it is 1, here it is 3, and here it is 5. Okay, here it is also 5, and here it is 10. Okay, now we know the larger terminal is positive, smaller is negative. This is positive, this is negative. Okay, and this, okay, this is 1 ohm, this is 3, this is 5. Now I will consider I1, I2, I3 according to my first step. Okay, this example is very important, guys. If you have observed first and two, in case if you have missed the first and two examples, you can push forward the video and see this third example, because third example is too much important rather than first two. Because in this example we will solve all the three equations using Cramer's rule, and uh, because we can't solve those three equations directly on calculator. Okay, in exams we have to solve by Cramer's rule, and in case if we have to verify our answers, we can use our calculator. So how to solve this? We will apply KVL to each and every mesh. So first I will apply KVL to first mesh. So I will write I1 as 1, I1, then 2. Now here I1 and I2 both are flowing through 2 ohm resistor, but I am considering first mesh, so I will write I1 minus I2. Okay, I will write I1 minus I2 is equal to, current is flowing from negative to positive, so I will write 5. Now I will add this 2 and I will write 3 I1 minus 2 I2 plus 0 I3. Now I'm adding here 0 I3 also, because here I am assuming 3 unknowns. That is why I'm writing 0 I3 also, equal to 5. So I got my first equation. Now I will solve my second equation. So in second mesh, we can see I2 is flowing through 2, 3 and 3 ohm resistor. So first we will consider this 3 ohm resistor where only I2 is flowing. So we will write 3 I2 as per KVL. Then through this 3 ohm resistor, I2 and I3 both are flowing. And as we are considering second mesh, we will consider I2 minus I3. So plus 3 into I2 minus I3. Okay. Plus 2 I2 minus I3. Now here 2 I2 minus I1 will come because I am considering second mesh. Plus 2 I2 minus I1 equal to 0. Because there is no voltage source in this mesh, so I will write equal to 0. Now I will solve 3I2 plus 3I2 plus 2I2. That it will give 8I2. So I will write here 8I2. Then minus 3I3. I will write here minus 3I3. My order is disrupted, but it is okay. We can arrange it afterwards also. Minus 2I1 equal to 0. So we got our second equation also. Now similarly, we will solve our third equation. And this time we will be using Cramer's rule. Okay. Now in this third mesh, we can see I3 and I2 both are flowing through 3 ohm. So we will write 3 I3 minus I2 because we are considering third mesh. So 3 I3 minus I2. After that, if we move forward, we are seeing that 5 ohm resistor is being observed. So current is flowing through 5 ohm, that is 5 I3. And then we are coming across a voltage source. Now we will write all the voltage sources towards right hand side. So here now we will don't write, we are not writing here equal to 0. Here we will write equal to 10. Okay. Now it will come 3I3 plus 5I3, that is 8I3 minus 3I2. 8I3 minus 3I2. 8I3. 8I3 minus 3I2 equal to 10. Also I have to write 0 I1 because I1 is not flowing through this mesh. So I got my all the three equations. Okay. Now we will solve these three equations using Cramer's rule. So how we can solve? So I will clear my diagram for space. So in Cramer's rule, you have to use a concept of matrix also. So here we have to consider Ax is equal to B equation. Now here our A will be a matrix which will involve coefficient of all these equations. Now here my first equation here, my first equation I will write in order. First I will write coefficient of I1, then I2, then I3. First I will write -2, then 8, then -3. So -2, 8, okay, -2, 8, then -3. Then I will write for second equation, that is 0, 8, and no, 0, -3 and 8. 0, -3 and 8. 0, -3 and 8. 0, -3 and 8. And for third I will write 3, -2, 0. 3, -2, 0. This is our A matrix. And in X we will write I1, I2, I3. X matrix denotes a matrix of unknown values. So I1, I2, I3 is a column matrix where we have to find values of I1, I2, and I3. In B matrix, we will write all the constants that are present on right hand side. So in first equation, we are seeing 0. So we will write here 0. In second, we are seeing 10. So we will write here 10. And then in third, we will write 5. Okay. So now how to proceed? So first, we will calculate delta. And then we will calculate delta 1. Now, what is this delta and delta 1? Actually, delta represents determinant or magnitude of this matrix. Okay, delta is the value of this matrix, and I will tell you about delta 1. So first we will find delta. So I will erase my equations. Okay, so first we have to find value of delta, and then we have to find delta 1. Okay, so how to find delta? So we will apply concept of determinant. So -2 into cross product of these two elements. So 20 into 30, 60, minus 24. 8 into 3 is 24. Then minus sign for second column. 8, -3 and 2 will be neglected. And -2, 8 and -3 will be neglected. So 20 into 0 minus 24. So 20 into 0 is 0 minus 24. Then we will write plus. Okay, after writing plus, we will write here -3. Okay, plus -3, that will be -3. So plus into minus is minus. So we'll write here -3. Write here -3 into We'll skip this column and this row, and we will write 0 minus of minus 9. 0 minus of minus 9. So it will become plus 9. Now we will solve this equation and we'll get an answer. We can solve this equation on calculator. So it will come minus 2 into 16 minus 24 plus 24 minus 27. So here we are getting minus 75 as delta. Now we will find delta 1. This is our value of delta. That is minus 75. Okay, now we will find delta 1. So how to find delta 1? So first of all, we will create a new matrix now. We will create a new matrix for delta 1 because delta and delta 1 are different. So both won't have same matrix. So how to proceed? So this is for delta. So what I will do for delta 1, okay, this 1 represents first column. That is this. Okay, this entire column. Okay, a 3 is coming. I will write minus 2, 0, 3, 8, minus 3, minus 2, minus 3, 8, 0. This is our A matrix, okay, which we calculated delta. Now we will calculate delta 1. So for delta 1, what we will do? We will replace 0, 10, and 5 with minus 2, 0, and 3. That is, we won't write minus 2, 0, 3. Instead, we will write 0, 10, and 5. That is, we will replace first column of this matrix with 0, 10, and 5. And the rest two columns we will keep as it is. That is 8, minus 3, and minus 2. Minus 3, 8, and 0. Okay. Now we will solve this matrix and we will find value of delta 1. So delta 1 will be equal to, so 0 into anything is 0. So we will move on to second column. It is minus 8 into 10 into 0 is 0. 0 minus 40. So it will come 0 minus 40 and minus 3 into, here it is 10 into minus 2 is minus 20, and here minus minus plus it will become 15 plus 15. Now we will calculate value of delta 1. So here it will come minus 8 into minus 40 minus 3 into minus 5, because minus 20 plus 15 is minus 5. So it will give 335. We are getting answer as 335. Minus 8 into minus 40, 320. Yes. Okay, we are getting 335. Now this is the value of delta 1 and we have got delta. Okay, we have got delta 1 and delta. Now we will find I1. Okay, we will find I1. So how to find I1? We will divide delta 1 upon delta. Okay, whatever is the value of delta 1, we will put it, and whatever is the value of delta, we'll put here. So delta 1 is 335. Okay, delta 1 is 335 and delta is minus 75. So on dividing, we will get our answer. That is 335 upon, we are getting minus 4.46. We are getting our answer is minus 4.46. 6. This is value of I1. Similarly, we can calculate values of I2 and I3 also, and we can cross check with our calculator whether it is coming or not. So what I will do, I will cross check it for minus 4.46. Okay. So I hope you got idea of how to solve mesh analysis, okay, using Kramer's rule. If you like this video, then do like, do share, do subscribe, okay, and thank you.